All right, let's talk a little bit about the geometric series. All right, geometric series have this form. So this is first term is a, and as you go to the next term, you multiply by r. So you're gonna have next term would be a r. R is a fixed number, and then next one is of course a r squared and a r cubed, and so on. And this keeps on going, right? Then in order to find the actual sum, what we need to do is we have to find the partial sum, right? So we need to take the limit. Remember that we want to take the limit of the partial sum, right? So let's find the partial sum. So Sn, S sub n would be, right, first term is a, next term is ar, and so on. And the last term is going to be ar to the n minus 1, right? So there are n terms here. Then what we're going to do is I'm going to use the trick we used before. We're going to multiply the entire equation by r. So it's going to be r times Sn, and this is equal to, right, a times r is ar, and ar times r would be ar squared, which is the next term, and so on. Then you're going to get the last term, ar n minus 1 times r would be ar to the n. Right? So I'm going to go through the subtraction. Right? Right, so you can see that the 1Sn minus Rsn is going to be quantity 1 minus R times Sn, right? Right, A minus 0 is A, and you can see that AR minus AR, they cancel each other out, and AR squared minus AR squared cancel out, and so on. So these are all canceled out up to AR to the n minus 1. So this is canceled out. Right, last term would be 0 minus AR to the n. So it's going to be minus AR to the n. Right, we can pull out the A because A is in common. So you have 1 minus R to the n. Alright, since we're looking for the partial sum Sn, so we're going to just divide through by 1 minus r. So divide through by 1 minus r. So we get Sn to be, alright, so you have a times quantity 1 minus r to the n, and then all over 1 minus r. Alright, so this is the partial sum. So I'm going to put the partial sum up here. So we're going to take the limit. So a times quantity 1 minus r squared over 1 minus r. Alright, and this limit is actually going to get a different result depending on the r value. So here, only thing that's affected by n is r to the n, right? So if the absolute value of r is less than 1, so you have a small number. If you raise a small number to a large power, it gets smaller and smaller and eventually approaches 0. So, so this is going to be equal to, right? So if r value, absolute value of r value is less than 1, like 1/2 or negative 1/2 even, and if you raise that to a higher and higher power, it's going to shrink to 0. So as n approaches infinity, r to the n is going to approach 0 if absolute value of r is less than 1. So this approaches 0. What's left is a times 1 over 1 minus r. So that the sum is going to be a over 1 minus r, right? So this is the formula for the sum of the geometric series when it converges. So you get a finite value. But if absolute value of r is greater than equal to 1, so let's just say like 2. But if you raise 2 to a higher and higher power, you can see that it's going to get larger and larger and larger and goes to infinity. So it's going to blow, it's going to be, let's see, it's going to blow down to, it's going to be, sorry, I have to. It's going to blow up to infinity. All right. So what happens is this is you're going to get a divergent. All right. All right, so the geometric series converges to A is the first term over 1 minus R. R is the number you multiply each term to get to the next term. So you multiply by R and multiply by R and so on. All right, so that's R. But if absolute value of R is greater than 1, it's going to go up to infinity. Right, or actually I should say divergent. If it's negative, it doesn't quite go to negative infinity, just that limit doesn't exist. All right, so let's look at this example. All right, so you have a geometric series, and we have to figure out what the A is. In this case, A is you plug in the very first number, so n starts from 1 and plug in 1. So negative 1/3 to the 0th power is 1, so it's a 2 times 1. So in this case, A is equal to 2, right? And then our value is pretty obvious. Our value is here. This is negative 1/3, so negative 1/3, right? Then if you look at the R value, if you take the absolute value of R, which is positive 1/3, which is less than 1. So we have this top case where we have the actual sum. The sum is going to be, right, A is 2, and over 1 minus R. R in this case is negative 1/3, negative 1/3, right? So this is going to be 2 over, right, 1 plus 1/3 is going to be 4/3, right? Right, so what we can do is I'm going to simplify, multiply top and bottom by 3, and we end up getting, let's see, and also we're going to cancel 2 and 4, you're going to get 2 here, right? So you're going to get 3 on top, right? And then 3 and 3 cancel out here, and 2 on the bottom. Right, so we have the answer here. So we have a solution. 3/2 is the sum of this geometric series. All right. Let's look at another example. All right. And as you can see here, if you want to find the A value, right, so this might be tricky, but all you have to do is look at the starting number. So n equals 0 is the starting number, and you plug it in here. So 3/2 to the 0th power is going to be 1. Anything to the 0 power is 1, right? And R value is going to be, you can see that every time you go to the next term, you multiply by 3/2. So it's a 3/2, right? And if you look at the absolute value, which really doesn't change anything, but you can see that the absolute value of R is greater than or equal to 1, right? Which means that this geometric series is actually divergent, right? So we don't have to do any more work because sum actually doesn't exist because it's going to blow up. All right, that's it. I hope that this was clear.